Do you know what's a math teacher's favorite kind of tree? Geometry.
Okay, so that was 8.52. Let's move on to the next one. All right, 8.53, estimate a population proportion. You can also use confidence intervals to estimate a population proportion. And that is annotated by a P or italicized P. Just a quick review, a proportion is just a fraction, which is the number of members in the population with a particular characteristic divided by the total number of members in the population. Like the population mean, the population proportion is often difficult to determine. Instead, the sample proportion, so here I'm going to draw a P, see if I can do this, we did this before, and you draw a hat on it. P hat is used to estimate P. So again, let's just say at Savannah or CVA, I can't get everybody, I can only, maybe I just do Mr. Ng's class and interview them. That sample tells me about the population. A sample proportion is the proportion of successes in a sample. Success, underline that, success. P hat means success. The proportion of failures, use a different color, underline it, failures is represented by Q hat, because Q has a hat. The proportion of successes, P hat, is given by P hat is equal to X divided by N. X divided by N, where X is the number of successes and N is the sample size. Basically, it's making it a fraction. That's what we talked about, number of trials. Failure, the proportion of failure, which is Q hat, is Q hat equals 1 minus, pay attention, P hat. Okay, why is that case? Let me give you my little shortcut here, okay? Rain plus no rain equals 1. Okay, why did I say that? Because the probability that it rains plus the probability that it's no rain, Q hat, equals 1. And if you just move the P over, subtracting P hat from both sides using your algebra skills, you get Q hat. Let me show you. One minus P hat. Okay? So think about, that's the best one. Rain plus no rain equals 100%, right? I look outside, it's really blue right now, so the chance of rain is 0. 0 plus 100% chance there's no rain equals 100% or 1. Okay, number 6. Like the sample mean, P hat is an estimate and will likely not equal the population proportion. Therefore, a confidence interval using P hat and a maximum error of estimate, E, we've talked about E before, is used to find a range of values within which P likely falls. Number 7. Here's the formula. The maximum error of the estimate E of a population proportion is given by E equals, oh, we've done this before, Z, seen that before. Okay, this one's different. Big square root P hat times Q hat divided by N. Okay? And We've talked about all those before. And I have some steps below. All right, steps to estimate the population proportion. Finish number 8. Okay, number 1, find the proportions of success and failure. Okay, so what is that? That's P hat and Q hat. Remember, you add those together and it equals what? 1. Step 2, find the sample size. What letter is that? That is letter N. Number 3, identify the corresponding Z value. So if we get a confidence interval, we can use our chart to find that Z equals some kind of number. Does that make sense? Number 4, find the maximum error of the estimate E. Well, we've already done that. E equals Z times S divided by the square root of N. But this one, sorry, that estimate though, and then we can still use that to get P hat. Number 5, the confidence interval of the population proportion is P hat is plus or minus E. So how is that linked to what we did previously? We kind of did a range. We did something like this. You guys remember that? That's pretty much the same thing, because just want to show you guys mathematically. It comes, last time you guys saw that was from the quadratic formula. There's a plus or minus. It's actually 2 problems. Okay? All right, let's try that with the lunch period. This is in your textbooks, if you wanted to know, on page 406, example number 3. A survey of 150 students, so I'm going to stop, and as I read, I'm going to annotate. N equals 150. At West High School, ask them if they agree with the administration's plan to split the lunch period in 3 different periods. With 72 response saying they agree. So this is kind of like you like it, right? So 72, this is my number of successes, X, okay? Use a 90% confidence interval to estimate the population proportion of all, so now they're telling me, of all 1,334. Okay, so we didn't talk about this before, but I'm just gonna tell you now. I did 2 types of n's here. I have a lowercase n, which is my sample size, and capital N represents the population. Okay, let's see if I can help you remember that. Sample and population. Watch. So sample, lowercase, and population, capital N, because that tells you everything. Okay, so what do we need to know? We need to know what success is. Success in this problem, let's just define it. So step number 1, P hat is X over N. So that is the number of people who agree, 72. Let's split up your whole lunch into 3 lunch periods, and our total there on our survey, lowercase n, is 150. Okay, so P hat is going to be 48%, 0.48. Okay, watch this. Q hat is basically the complementary, we call it. So 150 minus 72 equals 78. So P hat is really 78 over 150, because those are the people who are saying, nah, I'm not in agreement. And if you do the math, that would be 0.52. Okay, so you have P hat and we have Q hat. Okay, that was step number 1. Okay, step number 2, we already know what the sample size is. Step number 2 is the sample size is 150. Okay, basically if you think about what we're doing, we're just getting all of our variables ready to put into the formula. That's all we're doing. All right, step 3, our confidence interval of 90% basically gives us a z-score. Look back at your chart. Looking back at my chart, come to me chart. Uh, 1.645. Okay, step 4. Find the maximum error of the estimate. Now, before we do this, we need to make sure that our proportion have a large enough sample size. And in order to do this, we're going to have to do a formula. So I don't have this, but I could do step number 6. I don't know, let's call it step 0. I think that's better. Step 0, let's write that. Step 0, I'm going to call it check conditions. Check conditions. And really, we should have n p hat is greater than or equal to 5, and n times q hat is greater than or equal to 5. We're making sure that we have the right condition, so I'm going to do that up here. Where am I going to put this? Down here. Kind of out of order. So step 0, I have n times p hat is greater than or equal to 5, and n times q hat is greater than or equal to 5. Okay, so our sample size was 125, and our p hat, so let me color code it. Let's go back. N is 150. Where did I get 125 from? It is 150. That is correct. Why did I write 125? I don't know, Mr. Ing. Now I'm just talking to myself. Okay. 150. And then my p hat is 0.48. And is that greater than or equal to 5? Put that into my calculator right here. 150 times 0.48, and that gives me 72. So 72 is greater than 5. So that's yes. Okay, q hat 0.52 greater than or equal to 5. 150 times 0.52, that gives me 78. 78 is greater than or equal to 5, and that is also true. So step 0, we've met these conditions. Step 0 is check conditions. Okay, so we did step 0, step 1, step 2, step 3. Step 4, we are now finding the maximum error of estimate. So E equals Z times the S over square root of N. Okay, so well, I want us to notice that the formula we had above here, I don't have an S. So I'm going to use the one in the yellow box. Well, duh, that shouldn't have made sense. Let's try that again. So over here, you need square root of p hat, q hat over n. Let's write that. E equals Z times p hat times q hat over n. Okay, our Z is 1.645. Okay, so same thing with this thing. Don't be scared of it. P hat is over here. Oh, wasn't highlighted. Just throwing things around. 0.48. And q hat is 0.52. And the n value, where'd you go? Come back. Our n value is 150. Okay, so take a picture, then I'll put it on the calculator with you. All right, so bump. Clear, I have 1.645 times parentheses. Okay, I'm going to do second x squared by 7. Then in here, I'm going to do parentheses to notate the numerator. 0.48 times 0.52. Close the parentheses, divided by 150. Out of there. And then I'm going to close the parentheses. Okay? That gives me a number of 0.07. E here represents 0.07. Okay, then step 5, the confidence interval of the population is, let's write that. Step 5, we are taking our p hat plus, you could be consistent with what we did previously. Let's just do minus first, doesn't matter. And p hat plus e. Okay? So, p was 0.48. And E was 0.07. That's a plus, that one's a minus, so I get 0.41 to 0.55. So, my sentence, this sentence is shorter, and feel free to use it again with what percent confidence? 90% confidence. The proportion of students agree with admin is between 41% to 55%. So not a big group is really really going well with the admin. Okay, directions. In questions 7, 8, and 9, skip one problem below. So go ahead and cross off one of those. And if you want to do it with me step by step, press play, or you can kind of fast forward to just check your answer, see if you're doing it correctly. Part-time job. A survey of 120 students, so there's my lowercase 120, at South Grove High School asked if they agree that high school students should have part-time jobs, with 93% of the response saying they agree. So there's my X, there's my success. Use a 90% confidence level to estimate the population proportion of all 1,532 South Grove High School students. Okay, so the first thing I'm going to do is my p hat. P hat equals x over n. And I have 93 over 120. So if I put that into my calculator, 93 divided by 120 gives me 0.775. Okay, that means q hat, you can just do 1 minus 0.775 equals 0.225. Because remember, if you add these two numbers together, it equals what number? 1. Rain plus no rain equals 1. Okay. Got that. Step 2, we need a sample size. I I forgot, step 0. Let me just write this down. N equals 120. Let's do our friend who's a magic. I don't have to erase it. I can just do what? Ta-da! Whoops, I changed all the colors to black. Totally fine. Step 0. We need to check our conditions. So our conditions are n p hat greater than or equal to 5 and n q hat is greater than or equal to 5. Basically need to know that our sample size is big enough. So n equals 120. P hat, try that again. P hat is 0.775 and our Q hat is 0.225. Let's write that in there. Do we not highlight this thing? I just want to know that these are greater than 5, and I already know they're going to be. I just have that feeling. Right? And are our conditions met? Yes. That's supposed to be yellow. Try that again. Is that conditions met? Yes. Yes. Boom. Okay. We got our n values. Blah, blah, blah. Confidence interval z-score. Okay, let's get that. This one has a 90% confidence interval, so that basically means my z-score. Look at my chart, saved it on my phone. 90% equals 1.645. Okay, what do we need to do next? Find E. E equals z times the square root. Remember last time we didn't have the standard deviation, so now we basically have p hat q hat divided by n. Mathematically, it's the same formula. It's just that we don't have standard deviation, so you can take p hat times q hat, the square root of that. That doesn't make sense. That's okay. All right, try that again. I wanted yellow. This number, E equals 1.645. P hat, Q hat, and divided by N. Take a picture of this. Let's do that together. Might be a tricky one for you. All right. 1.645 times second x squared parentheses 0.775. Did you notice that p hat times q hat, or the blue plus green I had on the previous page, are equal to 1? .06. And then we're just going to do the step 5, which is p hat minus the e and p hat plus the e. So the p hat is 0.775. Our E value we just found 0.06. plus. So then my range, 0.775 minus 0.06 gives me 0.715, 0.775 plus 0.06, 0.835. Remember, as we talk about percents, you just, a decimal to a percent, you just multiply it by 100, so that would be 71.5%. Let's go to my friend who's a magic. And with 90% confidence, the proportion of students that agree students that have should have part-time jobs. Pretty high, right? You know, maybe you're working to support the family, or maybe you're just getting money for prom, or some students want to do like a senior trip. All right. A bus. A survey of 215 students at Landry High School asked if they ride the bus to school. With 46% of respondents say they do. Use a 95% confidence interval to estimate the population proportion for all 1,109 students. Step 0, let's check for those conditions. N times P hat greater than or equal to 5, and N Q hat greater than or equal to 5. Well, I need to get those from P hat. So P hat is X divided by N, which is our total of success, which is X, which is 46, and our N value, which is 215. And so if I put that into my calculator, 46 divided by 215. Okay, so I'm going to ask 0.214. So 215 minus 46 gives me 169. And 169, this is Q hat, divided by 215 will give me 0.786. Because remember, those two numbers equal to 1. So I can take this number, put it right here, Q hat, take that number, put it right here, N value, 215, and let's just fill it in here. 215, 0.214, is that greater than or equal to 5? Checking our conditions, 215 times 0.786. So 215 times 0.214 equals 46. That matches. 215 times 0.786. 168.99. Is that bigger than 5? Yes, it is. Good. Bam. Okay, what is our N value? Our N value is already 215. Step 3, I need the confidence interval of 95%. So look back at the chart at the beginning of the class. And I'm going to erase you because I'm looking at my phone. I can't read my writing. That says a 5. Come on, Mr. Rick. 5. 95% is 1.96. Okay. Step 4, let's find our margin of error. P has a hat, Q has a hat, divided by N. And our Z score is 1.960. My P hat is blue. Did it again. I always do that one, huh? There, there, there. There, there, there. And so 0.214, 786, and our N value we highlighted in yellow that came from the 215 up here. Let's put that into my calculator. I'm taking a picture of my math work. Alright. Boom, boom. Oh, look at that. Looky, looky, looky. Second enter. Save myself some work, kind of. 960. P was 0.214. 0.786. Ooh. See the mistake here? 2 decimals, bad. Okay, I know what happened. Okay, so I'm missing a parentheses right here. So I'm going to press second delete. And it created that space. I'm putting a parentheses right there. Okay. And then divided by 215. And I'm going for the home run. And the home run is I'm putting my whole formula all at once. You could do 1.960 divided by or multiplied by some number. But the home run is let the calculator do all that. The only issue you're going to run into is your notation of you putting it into your calculator. That's why I'm using extra sets of parentheses. All right. 0.055. 0.055. 0.055. Okay, now we just need to do step, what do we call it? 5. So this would be P hat minus E, P hat plus E. And this would give you, P hat was in blue up here. Point 214. And our E here. And if you calculate those numbers, question number 8, blah, blah, blah. Put in the calculator, 0.214 minus 0.055 will give us 1.59. And 0.269. And let's go to our friend Magic. What color you guys like? How about purple? Okay, what do we got? With a 95% confidence, I know we're gonna write something in there. And that number is going to change. At a 95 confidence, the proportion of students who ride the bus is between 15.9% and 26.9%. So at this particular school, not a lot of students are taking the bus. question number 9, a field trip of 245 students, n equals 245, at Jackson High School. Ask them if they agree with the principal's decision to have students pack their lunches for a field trip. With 102 of the respondents, so that's our success, x equals 102 of the respondents saying they agree, use a 99% confidence interval. Okay, 0, we're going to check the conditions, but in order to do that, I'm going to have to figure out p hat. P hat is the success over n. And my x value there is 102, and the sample, pay attention, the sample, not the whole school, just the sample is 245. So p hat is equal to 102 divided by 245.42. Okay, so that means q hat is just 245 minus 102. I should have done it in my head. 143 over 245, and that'll be the complement. So 0.58. Okay, so Q equals 0.58 and P hat equals 0.42. So more people are against the idea for right now, what we can see. And that formula is N P hat greater than 5 and N Q hat greater than or equal to 5. So 0.42, highlight the wrong thing, 0.58, and we need how many students? 245. Did I use green there? Okay. So 245 times 0.42. Is that greater than or equal to 5? And then 245 times 0.58. And is that greater than or equal to 5? So 245 times 0.42 gives me 102.9 students. That is bigger than 5. Yes, 245 times 0.58. And that is bigger. So my conditions are met. Okay. Step 2 was the sample size, and we already had that n equals 245. Let's just color code that because we already said it was yellow. Okay, step number 3. I'm just gonna yell at myself. It's okay, mistakes happen. Our confidence interval in this problem is 99%. So a 99% confidence interval gives me a z-score of 2.576. Okay, 4 is getting my estimate. Margin of error, E equals Z times square root of P hat times Q hat all over square root of N. And we said that Z goes here. And 0.42 green from over here. It's running out of the house. You gotta cover it up. And then our N value, which is 245. Blah, wrong color. 245. Okay, so 0.42, 0.58. And 245. Let's take a picture. Put it into the calculator. You want to see me do it all at once? Sure. 2.576 parentheses, close parentheses, open the parentheses down for the second part. And it's a big, my notation in the last problem, I realized that I didn't put a whole square root over everything. So second x squared parentheses, parentheses, so 0.42, 0.58. We're still inside the parentheses, divided by now the denominator, which is 245. And close parentheses, and that last parentheses is just showing that 2.56 times everything inside the radical sign, and 0.08. What I was trying to show you is, hold on, I'm gonna forget. Okay, so this here, hopefully you recognize it's the whole thing. And mathematically, I just want to show you this, that these are the same. Okay. All right, let's just finish this up. Let's do number 5. Number 5. P hat minus E. P hat plus E. So P hat is blue. 0.42. 0.42. And then minus plus, then E was 0.0. Highlight 0.08. And this question, number 9, then would give us 0.33. What? Let's see. .34 and 50. 0.50. And then if I take my magic and I'll put it right there and turn it green. Okay. What do we got? What do we got? So a 99% confidence interval. A 99% confidence, the proportion of who? Students who agree with the principal's plan is between 34% and 50%.
The new all-purpose ink man has arrived with all your favorite catchphrases like
It's time for game plans.
and capable of doing anything you need.
I use mine as a bookmark.
I use him to help teach my class.
It's time for game plans.
And for a limited time offer, you can get yourself a silly man too.